Hi, my name is Alexandre Givon. I will present the tool entitled TLS 1.3 Handshake Analyzer. I am a professor at Federal University of Technology, Paraná, and also I am a PhD student at Federal University of Santa Catarina. The presentation begins with the main motivation for developing this tool, followed by related works, methodology. We will also present a live demonstration of our tool, and lastly, the conclusions and future work. Common sense suggests the widespread usage of TLS for Internet security. And literature corroborates with examples in HTTPS browsing, embedded systems, microservices, 5G networks, and so on. TLS 1.3 is a security protocol defined in RFC 8446 in 2018. Nowadays, the major concerns of TLS 1.3 is regarding user privacy, since connection details of the user are exposed for passive attackers, and also it is vulnerable to future quantum computers, which breaks Internet security, in particular some cryptographic operations performed in TLS. Fortunately, solutions do exist for these problems. The first one is an encrypted client hello extension protecting privacy of the users by encryption. It protects the connection details, but requires a collocated server, which is responsible for decrypting the client hello message and redirecting the client to the desired service. The second, regarding the quantum threat, the Open Quantum Safe project provides cryptographic libraries and allows protocols to use post-quantum algorithms to secure their operations. However, since these mechanisms are recent, how can the effects of such mechanisms be examined and quantified? The table shows a comparison of existing SSL and TLS tools, where SSL is the precursor of TLS protocol. Most of them, some of them are open source, most of them show secure information, but none checks both post-quantum cryptography support and encrypted client hello support. In addition, some of them, not all of them, shows performance information about the connection, and not all of them provides a flexible user interface by providing command line interfaces and web interfaces. In this context, we introduced the TLS 1.3 Handshake Analyzer tool. The main features of this tool is that it supports the analysis of TLS 1.3 handshakes, providing or not the TLS keylog files for decryption. It allows to analyze about the presence of quantum-safe algorithms and ECH extensions. Also checks the security of the cipher suites in use based on the web service named ciphersuite.info. And also display handshake statistics and the size of the handshake TLS exchanged TLS objects. Lastly, it provides also a flexible interface by providing both a command line interface and a web interface for users. And the main objective is to help users to better understand the security and performance of their TLS connections, given that these recent mechanisms, such as the quantum safe algorithms and the ECH extensions. The design of our tool begins by the user choosing which interfaces he wants to start. The main requirement is that the user must provide a capture file containing the TLS connection handshakes. So the TLS tool starts parsing the messages inside the capture file, aided by the PyChart module. Then it starts retrieving the handshake information, such as the cipher suite, the key exchange algorithm, and the digital signature algorithm in use. These ones are compared to a local database of quantum safe algorithm object IDs for checking whether the quantum safe algorithms are in use. And for checking the cipher suite, an external service is used, named as ciphersuite.info, to check the security of the used cipher suites. Lastly, the tool computes the handshake statistics and returns to the user the results. Now we provide a live demonstration of tool. The demonstration of the TLS 1.3 handshake analyzer starts with the Docker build of the image, and then we can execute the tool using Docker run, passing as parameter the IDE parameter which starts the web interface. We can access to the tool interface with a browser, and then the user provides a capture file for his TLS handshakes that he wants to analyze. Optionally, the user can provide a TLS keylog file which contains the cryptographic material of these connections, and checking with the ciphersuite usage and the encrypted calling hello extension are present. The tool returns a graphic which shows the sizes of TLS messages, such as client hello, server hello, the handshake signature, and the certificates. Also, the tool shows statistics of the handshakes, such as average size and standard deviation, also average time and standard deviation. The security information includes for the key exchange algorithms and authentication algorithms, if the algorithms are quantum safe or not, and also shows if the handshake supports for ECH extension. If an insecure ciphersuite is used, we check it with the ciphersuite.info web service, and also in the end of the tool we show performance information. The tool also provides a download for the plot, and also provides a reset. This concludes the demonstration. In conclusion, the privacy and quantum safe requirements are being resolved by different mechanisms. However, there is a difficulty for users to analyze those mechanisms and understand their impact in performance. Aided by our specialized tool, users can visualize and better comprehend information about their connections, given that they provide the capture files. On the other hand, the capture file requirement limits the usability of our tool. Therefore, for future work, we want to improve our tool's usability by providing a live capture mod for our tool, allowing an easier and real-time evaluation for the user's TLS connections. Thank you for your attention. Now I am available for questions. Thank you.